Hi guys, and welcome to this, our final video of the data analysis section, and it's the last one on time series as well before we move on to the next core data section on the website. It's really good to see you. If you haven't already done so and you think you could, there's a doohickey in the corner that I would greatly appreciate it if you could click and subscribe. Turn on that little notification bell and tell your mates as well. The whole of the Further Maths course is going to be uploaded over the next few weeks and months, and hopefully it is helpful for you. Now, as I say, we have dealt with trends and cycles and all that type of stuff previously in previous videos, and we're just going to bring it all together now with this trend line and forecasting. What on earth does that mean? Well, as I say, as usual, having spent all of this time doing the previous videos, then life changes because they're going to throw a curveball in. And actually, the only curveball they're going to throw in, ladies and gentlemen, is they're going to change the language again, right? So beforehand, we have predicted, and now we're going to change that to one word: forecast, right? So for time series data, for some reason, we have trend lines, which are nothing more than lines of best fit, and we now have forecasting when it has prediction. And pretty much, if you want to, stop the video now. I'm joking. There are a few examples coming up. All right, so fitting a trend line. As I say, it is no different than what we've done before. In fact, in a previous video, that's very much what we did for our deseasonalized data. So we've got some examples here from Cambridge, Further Maths textbook. Thank you very much, Cambridge, for providing these. The year numbers are given 1981 all the way through to 1992. My mind is already going, well, I'm not going to put those into my spreadsheet or my statistics sheet. I know I'm going to have to number those 1 through whatever it'll get to. And I've got these numbers here, which is the number of government schools in Victoria over that period. Okay, well, realistically speaking now, the CAS is going to do all the hard work for me. Let's just zoom in just a little bit so we've got it bigger for you guys to see. We know we can put the CAS, we are going to number our years 1, 2, 3, 4, all the way through to 12. Now, there is a trick coming here, a huge trick that unfortunately lots of people fall foul of later on in the exam. So hopefully you'll be aware of this and not make the silly mistake. We have year and we have number. No different from what we've done before. We bang it in a calculator, we hit our little set stats graphs, we make sure one is switched on, XY line because it's a time series graph, year and number, and lo and behold, out comes my graph there of, I think this was already deseasonalized data. Nope, it's a trend line. What do we now do? Well, it seems to be that data doesn't need to be smooth. There's no way for me to smooth it. And so I'm going to do a regression analysis. So as we've done before, we hit the word calc, regression and linear regression, making sure once again to tell our calculator to do year, which goes on the horizontal, and number, which goes on the vertical. And up comes my formula, or at least the values I can put in my formula as a plus bx. We know the value of a, and the value of b is going to be really, really important. And yes, so actually, we know that the y value, if you remember, is number, the x value is year, and so we can now put number is equal to 2169, that's my value of a, minus 12.5 times the year. Bang, done. No different than what we've done before. We can also show that information on the graph, if you remember. So when you click OK on that previous dialog box, it's going to draw the regression line on for you. And if we want to, we can bring up this equation as part of my graph by hitting this XY button here on the Casio ClassPad. TI Inspire, I think it already does it for you. I genuinely can't remember at this moment. All right, so there we go. That's my line of best fit. Don't get tricked with things like the plus and the minus. Don't put that. And remember to swap out your values of X and Y for number and in this year. Now, remember, whenever we do this type of stuff, we have to ensure we interpret the slope. We knew the slope was minus 12.5. We got that data from my calculator. So now we interpret it. Don't put the minus sign, just use the word decrease. So we now know for every 1 unit increase in time, so for every 1 year, because that's what we were dealing with, we can have a decrease of 12.5 government schools, right? So hence, for every 1 year increase, we see that the number of government schools in Victoria decreased by 12.5. There we go. Easy, right? Now, we move on to the next section, forecasting. Forecasting is just predict. It's the same we've done as before. It's just taking values and predicting where we're going to go. They just call it forecasting. So we've already got our formula. If you remember, here is our formula. The number equals 2169 minus 12.5 times the year. And this is where our warning comes in. Why? Because we have changed our years. Remember, we put our years as 1, 2, 3, 4, 5, and so on. This here is never, ever going to be 2015. Okay? You are never going to put the actual year in there. You're going to put the year in that we have numbered. Yes, 1, 2, 3, 4. So if we go back to the question, or in previous question, it basically told us that we called 1981 as year 1. So 1981 we called year 1. And the question wants us now to actually predict how many government schools would there be in the year 2015. Well, I don't know about you, but I had to use my fingers and thumbs and toes and all sorts of other things to be able to work out, well, if 1981 was the first year, then actually 2015, as it turned out, was the 35th year. Now, there are no real shortcuts to doing this. There are, but they're confusing as all hell. So don't. In my advice, I would just count with your fingers and do what you need to do. And now that we have seen past that trick and we know that, in fact, our year is going to be 35, you just substitute it into your equation. So 2169 minus 12.5 times 35 gives me 1,732. And there we go. I've now predicted the number of schools in 2015. Oh, sorry, I forecasted. Don't get confused with the language. What about seasonality? Well, we know that to forecast with seasonality, what's the first thing we have to do? We have to deseasonalize our data, all right? So when we've been given our seasonal data, we deseasonalize it, and then you do exactly the same as we did before. So here is an example of the deseasonalized quarterly sales data from Mikey's Shop shown below. This is exactly the same example we just did. We've got our quarters numbered 1 through 12, and our sales figures, our deseasonalized sale figures were done for us, okay? And here we go. So our deseasonalized figure, there we go. We've got quarter and we have sales. And what do we notice? Yes, we have our graph is going up here, all right? So these are my deseasonalized sales. Now, if you remember back to the previous video, it didn't quite look as jagged as that. That was because it was plotted on with the original sales data and it just squidged it a bit, but it is exactly the same graph. Okay, what do we do now? Well, yes, we do our linear regression. So we've gone back and we've done what we needed to do. Now, there are calculator screenshots missing from this, but again, we've got our quarter and our sales. Click on OK, and up comes our values for A and B. So building on what we did in previous, all we're doing now, what's different? Just deseasonalize the data first. Doing that, we click on OK. Up comes our linear regression, and we hit our little X, Y button there to give me my formula, just to confirm that it gave me what it was before. And as we can see, we write our equation as sales, because that's what we're predicting, forecasting, is equal to 838 plus 32.1 times the quarter, and again the quarter. And because this is time series, we have to interpret the slope. Over the 3-year period, the sales increased at an average rate of 32 sales per quarter. Yes, again, for every 1 quarter increase, we went up, or my sales went up by 32.1. There we go. So that's where that 32.1 figure is. Making predictions with deseasonalized data. Oh my goodness, I feel like a broken record because we're now just going to do the same thing. Again, don't get tricked with this whole autumn, spring, summer, winter thing. You're going to have to come up with the number to place into the formula. But again, we were going to assume for this example for now that summer is that first quarter. Okay, this is going to be summer, autumn, winter, spring. Now, the question basically says, can we predict the sales for Mikey's shop in winter of year 4? Her actual sales. There's going to be 2 steps to this. Winter of year 4, well, the problem is we only have 3 years data. There is 1 year, there is 2 years, and there is 3 years. So I need to now extend my table out and work out what number would my winter of year 4 extend to. So I've done that for you below. We've got our first year, our second year. I've added just a row of data, third year and fourth year, just to make it a little bit more obvious. I'm quarter sales all the way up. I've extended that so that my quarter, I've gone all the way up to 16 now. And because I know that I'm starting with summer, autumn, winter, spring, summer, autumn, winter, spring, summer, autumn, winter, spring, and summer, autumn, winter, spring. It wanted winter of the fourth year, which means that our actual figure I'm going to put into my formula is 15. Scrolling up just so we can do that. What do I have? I have sales is equal to, yep, that's no different from the formula I had a moment ago. All I've done now is substituted quarter for 15, and out come my sales values as 1319.5, don't they? Well, my deseasonalized sales do, yes, but I want her actual sales. Oh, that's annoying. Now, if you remember, we're going to go back again. This builds on the previous video, and it sort of builds on the idea that we had our seasonal indices given to us for Mikey's shop anyway, yes? So we want to be able to now re-seasonalize my data. And so my re-seasonalizing data formula says to get my actual figure, take the deseasonalized figure and multiply it by our seasonal index. What seasonal index do I want to use? Well, we were dealing with winter of year 4. So there is winter of year 4. So my seasonal index there is going to be 1.3. We've got my actual figure from past in the question, which was 1319.5. And ladies and gentlemen, that would suggest her actual sales would be 1,715. Now, can you see that last part of that question there? Brilliant for SACs. Great for exam questions. Ties everything together in terms of least squares regression lines, deseasonalizing data, seasonal indices, the whole kit and caboodle. So hopefully this has been useful for you. This actually signifies the end of this video and the end of this part of the course. Thank you so much for watching. If you haven't already done so, could you subscribe by clicking that circle over there? Tell your friends. Otherwise, there are more videos dropping for this course all of the time. If you haven't already been over to maffsguru.com, please do so. Subscribe, it's free, or sign up, it is free, and all the videos are much, much better and easier to find than on YouTube. All right, I'm off. Have a good day. Thanks for your company. See you next time. Bye-bye.